Hello everyone, welcome back to the class manual. Hope you're doing amazing. Today we're trying to cover how to convert decimal numbers to binary numbers. You've probably heard of binary somewhere. You've seen the zeros and ones in the matrix or in your computer storage. You've heard the word byte or bit, megabytes, gigabytes. These all are binary system or base 2. However, it's mostly recognized as the binary system. For learning how to use the binary system, it's very helpful to know the powers of 2. So let's start with the powers of 2. To the power of 0, power 1, 2, 3, 4, 5, 6, and 7. Let's stop there. Let's stop at a byte, an 8-digit number in binary. Okay, so what is 2 to the power of 0? 2 to the power of 0 is just 1 to the power of 1, 2, 4, 8, 16, 32, 64, and 128. You can increase the power, but let's just stop here and try to convert a simpler number, such as the number 75. Number 75. Okay, 75. What is the smallest number here that we can have one of from these? From this group, which is the biggest number that we can have and contain in this 75? It's going to be 164. Remember, in a binary, it's either 0 or 1. You either have that number or you don't have it. Okay, 64. Now let's do 75 take away 64. We have 11 remaining. What are we going to do with that 11? Okay, let's do the same step again. What is the biggest number from this group left that we can contain in an 11? It's going to be an 8. So we're going to have one more 8. Now, you take away 11 minus 8, you're going to have 3 left now. What are we going to do with that 3? Again, the same step. The biggest number you can contain is 1, 2. And 3 take away 2, we're just having 1 left. And the only thing that you can contain in this is 1. Now, what you're going to do with the rest of the space? If you're writing it in a byte or a computer system, you may put a 0 here in 128. However, if you're just writing it mathematically, you don't even need this placement. You can just cross it out. And you can just put 0 for anything between the other ones that you have. So this will be our binary value for number 75. Now let's do it for another value, something that is even bigger than 128 perhaps. Now we can do the same process for a number such as 196. Now this is a much bigger number than 75. And this time you actually need the 128. Because if you go higher to 2 to the power of 8, you'll know that you will have 256, which is still not useful in this case. So we're going to stay in this same exact situation. However, this time we are going to use 128. The biggest number that we can have, 128. Okay, now we have to do 196 minus 128. This time we're going to have 68 left. Okay, that's not 68. We're going to have 68 left. That is ugly 6. Okay, don't mind me. 68. The biggest we can have is 164 in there. Okay? We have two ones next to each other this time. Of course, you know that 68 minus 64 is going to be a 4, which you will have right here. Now we're done. 4 minus 4, 0. The only thing that we need to place are the zeros in between. And this is going to be our binary value for this conversion. Okay, so I set it up quite nicer this time. Let's go for the number 365. Okay, so the number 365 has 256 within it. Now, if we deduct 365 from 256, you're left with 109 extra. What are we going to do with that 109 extra? So it doesn't quite fit in 128. So we have to go with 64. So 164. Now we have to deduct 109 from 64, which is 45. So 45. We can only put in 32 now. So 132. 45 minus 32, we're going to have 13. 13 doesn't go into 16, it goes to 8. 1, 8. 13 minus 8, we're going to have 5 left. 1, 4. And 1, 1. And we just fill in the blanks with the zeros. And this is our binary number. Another binary conversion. And I think that's good for today, because even if the numbers get bigger, you just have to increase these powers and you can just go and increase it to the left. The process stays the same. I mean, it is much easier with a calculator, and it isn't really used this much, but it is good to know how to convert it and how computers work, and use these bits, which are a single digit in a binary, to create bytes, which is still 2 to the power of 7, which are 8 digits of a binary system, 2 to the power of 8, 2 to the power of 7, through 2 to the power of 0. It is 8 placements, hence the 8 bits. And yeah, that's basically it. Hope you enjoyed this, hope you learned something new, and see you next time.